Embedded Controller Lab PWM experiment. We will try to simulate using Proteus. Few modification what you need to do it in your program I'll address, and you can do it and you can build the application. So the first we will look at the program which we had it for PWM signal. So this was the program for generating your PWM pulse. So modification for your LPC 2148 machine, delay program remains same. The header will be changed to LPC 21xx.h. Main program, instead of pin cell 4 we will be using now pin cell 0. The reason is you can go to this URL, explorembedded.com, and you can figure out the registers associated with LPC 2148 PWM module. So PWM 1 channel we are making use, and it is associated with the pin P00, whereas for your LPC 1768 it was associated with P20. So we were using pin cell 4 register, okay, and here we are supposed to use pin cell 0 register itself. But there is one difference: the function 0 function, if if the two bits for addressing this pin is set to 00, the function 0 is GPIO, the function 1 is transmit, and the function 2 is PWM, which means you take the bits 0 and 1 bit of pin cell 0 you have to select, and 1th bit should be made 1. So here placing data 2, placing data 2 implies 1th bit is made 1 and 0th bit is done 0, so you'll get 2. So 2 has to be loaded on pin cell 0 register. That is the only one difference. Then nothing, no more difference. So let me go to the program in Keel environment. So you have same code and pin cell 0 register. So it's very easy, easier than your LPC 1768 controller, because directly we can refer pin cell 0. Rather, in your Cortex M3 we were using this extra header LPC pin con, under which we were selecting pin cell 4. Now directly write pin cell 0. This can understand, ARM controller can understand it. Now here we have used PWM1 everywhere, so now just write timer control register, directly give TCR register. So I have given TCR register, so but it is associated with PWM, so write PWM TCR. Okay, so PWM TCR, here I have given it as 5. So I've indicated that third bit was to enable the PWM, and here it is the first bit is fair enough. Counter you can enable, and PWM if you want to enable it is in this documentation. You can refer for your TCR register. This pin is to enable the PWM third bit, which means 1 0 0 1 should be the value. 9 value you can load. I have not used this, so just 1 I have used. Counter enabling, if it is doing it, that's fair enough. So this is pin cell 0. Then PWM TCR, it is set to 1. Counter is enabled. MCR is made 2, and here again it was 2. Here it was also 2. That is to make MR0. As soon as the match occurs, it has to reset. It has to reload with the new MR0 value. So the same value it is, and PCR content is 200. It is same in this case, because when you go to PCR register, which happens to be PCR register 9th pin to 14th bit, which was same for LPC 1768. It was to enable your PWM, and PWM channel 1, if you want to enable 9th bit, we need to concentrate, and 9th bit is made 1. That's same. Then PWM LER, so your match registers MR0 and MR1 are made 1, and the duty cycle 100 and 0 you load it into match register 0 and 1 correspondingly, and even in the program you have the same thing, and this no change. So only remember this one, if you modify, it's fair enough. Pin cell 0 should be made as 2. Okay, remaining everything is same. So that's the program you have. So it was already explained, so I'll not be explaining again. So what you have to do, build the program, rebuild the program. Okay, so no problem. I hope this is fine. Now let's go to the proteus environment. In proteus environment, one extra component which you require is oscilloscope. We will see how to get this oscilloscope. So other than that, I'll just explain what and all modules you require. You require a LPC 2138 controller. How would you pick it? You go to this pick, and here you can type LPC 2138. So pick this module. Okay, pick this module. Already I have selected it, so I'll give cancel. Then select the ceramic capacitor. So to pick this, type capacitor, and under capacitor you are supposed to go under the subcategory ceramic disc. In ceramic disc, select ceramic 22 picofarad capacitor. I have selected this, so I'll not be redoing it. Then select the crystal oscillator. So here in the disk, type crystal. Okay, and select the device quartz crystal. So it's already selected. Okay, then one more component which you require is cell. So to select cell, go to pick library or device, and here type cell. So I'll get this uh, cell component. Pick this battery cell single component. Okay, that's what the component you require. And one more additional is oscilloscope. So for oscilloscope, you can see a symbol here with the multimeter symbol. You can pick this. So you have variety of instruments, out of which we will be picking the first one, oscilloscope. That's your digital oscilloscope. Okay, so this much you require. And the connection right now is just one line you have. Other than that, battery has to be given to this controller, and crystal frequency to XTAL1 and XTAL2, and again this has to be changed to 12 megahertz. Okay, then capacitors 22 picofarad I've selected. Then you can directly connect this P00. P00 is PWM1 second function it is. So we have already set the device for this. Then we can just simulate the program. Okay, after this much connection, simulate the program. So this is what you'll get. So you can turn off all the channels. Channel A is important, channel 2 is not. So what happens, so initially the pulse duty cycle is keeping on increasing. Once it reaches 100, then it will decrease. So this is what you will get. And channel 2, channel C I'll make it off, channel D I'll make it off, channel B I'll make it off. And just remember, right now the time I have made it 1 microseconds I have given. This is your time scale. This bottom is for time scale, and this is to configure your channel A. So amplitude, if you want to vary, you can vary the amplitude. Right now it is 2 volt. Can increase it the mode. And the position, XY position of this channel A can also be altered. So this is the position which you can use it for making the adjustment along Y axis, and along X axis you can use this to make the adjustments. Hope this made sense. So understand, AC mode you have to keep, and here trigger, this should be DC, this is 0, and yeah, that's all you have. So hope try to get this output. That's all fine.